So determine the DC bias voltage VCE and current IC for the voltage divider configuration using the approximate technique. So in the case of approximate analysis, what is the assumption you are taking? Approximate analysis, you are assuming that the current IB is approximately equal to 0. So it is very negligible. It is approximately equal to 0. Okay, and you have to check the condition. So the condition to be checked is beta into Re should be greater than or equal to 10 times of R2. So what is beta given? 100. What is Re? 1.5 kilo ohm should be greater than or equal to 10 times of what is R2? 3.9 kilo ohm. So whether you can check the condition. So 150 kilo ohm will be greater than or equal to 39 kilo ohm, right? 150 is greater, it is satisfying the equation. So we can proceed with the approximate analysis. Okay, so in the case of approximate analysis, since IB is very negligible, now if we have to find out the value for VB. So if I take this voltage as VB, you can apply the voltage division rule, right? So what will be your voltage division rule? So VB will be equal to, what will be your voltage division rule? The supply voltage VCC into, that is R2 divided by R1 plus R2. So what will be your VCC? What is VCC? It is equal to 22 volt into, what is your R2? 3.9 kilo ohm divided by, what is your R1? 39 kilo ohm plus 3.9 kilo ohm. So when you solve it, you will be getting 85.8 into 10 raised to 3 divided by 42.9 into 10 raised to 3, right? This 2 will get cancelled and VB is equal to 2 volt. So you will be getting VB is equal to 2 volt. Okay. So now here the total voltage is equal to 2 volt. But you know that this voltage is equal to VB, and if I take this as VE, right, voltage as VE, I can find out what is your VE. Now what will be your VE? So let me write the total voltage. I can write VB is equal to VBE plus VE. VBE plus VE. From this, can you calculate what is your VE? VE is equal to, what is your value? V is equal to VB minus VBE. VB already you have calculated. What is the value? 2 volt minus VBE, you know that it is 0.7. So what will be your VE? VE will be equal to 1.3 volt, right? So now you have got the value for VE. Okay. So now once you have calculated the value for VE, you can calculate what is your IE. IE is equal to VE divided by RE. So what you will be getting, VE is equal to 1.3 volt divided by what is your RE? 1.5 kilo ohm. Therefore, IE will be equal to, what will be the value? 0.866 milliampere, approximately equal to IE you have got, right? So when you know that IE is approximately equal to IC. IC is approximately equal to IE, which is equal to 0.866 milliampere. So you have got the value for IC. Now what is the next value you have to calculate? VCE. So you know that what is your VCE? Applying KVL across the output loop equation. In the last video we have solved. There is no change. So your VCEQ is equal to VCC minus IC into RC plus RE, right? So what will be your VCC? VCC is equal to 22 volt minus, what is your IC? Already you have calculated. So it is equal to 0.866 milliampere into, what is your RC? RC is equal to 10 kilo ohm plus RE is equal to 1.5 kilo ohm. Okay, so you will be getting 22 volt minus somewhere nearer to 9.97 volt. So your VCEQ will be equal to 12.03 volt. So your both the values, quiescent point values, ICQ Q, IC is equal to 0.866 milliampere, and or you can approximate it to 0.867, and VCE will be equal to 12.03 volt.